All right, hi everybody. The title of this unit lesson, is 4.6, Solving with Complex Solutions. And so we're still going to be basically doing the same strategy as we did yesterday. It's just that this one has some new kinds of answers. And so let's just kind of treat this problem like we did yesterday and explore why we need to care about this. So if I subtract 2, I get 2x squared equals negative 2. And then if I divide both sides by 2, which is what we would normally do, we would get x squared equals negative 1. And then we would have to say, well, then x equals plus or minus the square root of negative 1, which doesn't seem like it would be a problem, except for then when you type it in your calculator, you get an error. The square root of negative 1 doesn't actually exist. It's an error. It's not real. And so we have to make up something to explain what it is. And so mathematicians have decided to call this thing I. And so we would say x equals plus or minus I as our answer. That kind of is a workaround for mathematicians because mathematicians don't like it when there's an error. And so we have to say, well, how do we represent our answers even if it doesn't really truly exist in the real world? Because there is no number where you square it and you get negative 1, except now we just created one. It's called I. So the definition of I is that it is the square root of negative 1, and therefore I squared is equal to negative 1. So this, we could say, definition of the imaginary number. Okay, so that's the imaginary number. You should write this down in your notes. So I'm going to have you pause the video, copy this problem, and then write down the definition of I. There are a bunch of problems here where we should try some of these. I'm just going to do a couple ones that I think we really need to focus on. The first one is this first one. Really, it's set up for us to just take the two square roots. So we should be able to say x equals plus or minus the square root of negative 36. And so then we need to think about a little bit about square root. We can split this into x equals plus or minus, well, 36. Square root of 36 times the square root of negative 1. Those two things are equivalent. Well, but the square root of 36 is just 6, and the square root of negative 1 we know is I. So we can say plus or minus 6i is what x is equal to. So that's our first answer. The next one I want to do is one like this. Because I think this one is also instructive. It's a little bit weird. We should maybe subtract 42 from both sides. And we'll get negative x squared equals 23. Then I need to divide both sides by negative 1. And I get x squared equals negative 23. And then when we take the square roots of both sides, we will write x equals plus or minus the square root of negative 23. And again, we can just write x equals plus or minus the square root of 23 times the square root of negative 1. Well, square root of 23 isn't a nice number. It's, let's see, 4.795. Something like that, 4.796. Well, I'm just going to leave it as square root of 23 because just like we talked about yesterday, that's an exact answer. But I am going to write the I first, and then I'm going to write the square root of 23. It's kind of a convention thing that we put the imaginary number before the square root if it's, if we're really being picky. Okay, one last problem to try, which is this one. Because this one seems like it's equal to a negative number, so it seems like I would have to do all this work. But in fact, we should maybe look at what happens, because really I'm seeing that it's not a vertex form, and it doesn't look like it's going to be the same strategy. So I think I actually need to look at, does it factor? The move I'm doing right here is I'm adding 12 to both sides to get this to look like this. And so there's actually kind of a couple in here where some of them come out with real nice answers, real answers, excuse me. -6 and x equals -2. All right, so I put some other problems here that I think you should try if you want a little more practice, but these are some good example problems. And then the green one that I just did is another review problem of what we've done in the past. So we're kind of continuing to cycle here. Okay, let's keep going. In here, well, Again, we need to take the square roots first. So we're going to say x minus 2 equals plus or minus the square root of negative 49. Remember, I can split that into the square root of 49 and the square root of negative 1. And the square root of 49 is just 7. So we'll write x minus 2 equals plus or minus 7i. We're not quite to the point where x is by itself yet, so we just have to add 2 to both sides. We'll get x equals 2 plus or minus the square root of, 2 plus or minus 7i. These are not like terms, and so you just have to keep them like this. You cannot combine the 2 and the 7 to write 9i. They're not like terms. The 2 is a real number, and the 7 is a imaginary number. Okay, the next one. Divide both sides by negative 2, and I get x plus 1 squared is equal to negative 25. Maybe you can see where this is going. I get x plus 1 equals plus or minus, and I'm just going to skip to 5i here because the square root of negative 25 is the same as the square root of 25 times the square root of negative 1, and 5 times I is what we get. So we get x equals negative 1 plus or minus 5i. That's my answer. I'm going to let you leave the other two to you to try. These are going to be a little bit harder because the square roots don't simplify very well, but remember you can keep it exact and you do not have to actually get answers, decimal approximations. You can just keep the answers. All right, so we still have those 2 ways to solve, but this strategy number 2 that we talked about yesterday and today now can lead you to imaginary solutions. So the worksheet today has some problems where you have to do imaginary solutions, like we just did in class today, and then some of them actually come out with nice real answers too. So the answers are on the back as always. Just be careful. I think you'll have plenty of time to do all these problems, but I really want you to focus and really try to write every single step down while you do the work. Be focused, be on task in class. I will see you all tomorrow. I promised you that you would have the homework tracker, and so I'm going to upload that as a link on the assignment so that you have access to that. I want you to take a second to take a look at that and do that. Okay? So I will see you all tomorrow. I hope you have a great day. Goodbye.